Hello everybody, today we're going to solve a system of linear equation using matrices. So we have a system of three linear equation, and to solve this system of linear equation by using matrices, the first thing you need to do is to write the augmented matrix for the equation. What is the augmented matrix? The augmented matrix are the coefficient of x, y, and z and the constant. For the first equation, for instance, the coefficient of x is 1. So that's what we have 1 here. Coefficient of y is 3, and here we have 3. Coefficient of z is 2, and here we have the bar, and anything we have here is a number after the equal sign. So in the first equation, we have -3. That's what we have in -3 here. We're going to be doing the same thing for equation 2 and 3. For equation 2, the coefficient of x is 2. The coefficient of y is -5. The coefficient of z is 3. The constant after the equal sign is 8. Again, we'll do the same thing for the third equation. We have 3, -1, 4, and 7. And this is what we call the augmented matrix. The augmented matrix. If you notice, the first column in the augmented matrix represent the coefficient of x, the second column represent the coefficient of y, and the third column represent the coefficient of z. Now, to solve using matrices, we need to transform the augmented matrix into a matrix that looks like this. If you notice, all the values in the diagonal here are 1, and anything under that diagonal is 0. So we have the lower triangle here are all zeros. A, B, C, D, E, F are just numbers. So in a matrix that looks like this is called a matrix in row-echelon form. The row-echelon form, that's because the diagonal is 1 and anything under the diagonal is 0. This can be easily solved because now we can solve for z from the third equation, because x and y, the coefficient of x and y are 0, so you just find z. From z, you plug it in the second equation to solve for y, and after you solve for y from the second equation, you plug it in the first equation to solve for x. So we need to solve this, that's what we need to get in order to solve the system using matrices. The question is, how do we go from the augmented matrix to row-echelon form? Well, we're going to have to follow 3 rules. These are the rules. We're going to be using row operations. Sometimes they call it elementary row operation or ERO. These are the 3 operations that you can do. You can interchange any 2 rows. Sometimes you do that, but not a lot. You multiply a row by any real number except 0. So you can multiply any of the rows by 2 or 3 or 5 or 1/3. And then you can add a non-zero multiple of 1 row to another row. And this we're going to be doing a lot. Basically, you multiply a row by a number like 1/2 and you add it to another row and you leave the answer in the other row. So we're going to use these row operation to transform this augmented matrix to a row echelon form. Okay, so let's go ahead and do this. So I have here, I've written down the augmented matrix, and let's go ahead and make the diagonal 1 and everything under it is 0. Well, the first one is already done, so we're good. Okay, that's the first thing you look. You make sure this is 1 and that's already 1. Now we need to make anything under it 0. So the way you can make this 0, we're going to use the third row operation, multiply a non-zero number by a row and add it to another row. So if I multiply the first row, I'm going to call it R1 for row 1, by -2 and add it to row 2. So if I multiply this by -2 and add it to row 2, what am I going to have? -2 times 1 is -2, -2 plus 2 is 0. So that gives me the 0 that I want. You multiply R1 by -2, add it to row 2, and leave your answer in row 2. That's what this does. So let's go ahead and do this. I'm not changing the first row. I'm going to write the first row as is. Now, multiply the first row by -2. -2 times 1 is -2. -2 plus 2 is 0. and leave your answer in the second row. Negative 2 times 3 is negative 6. Negative 6 plus negative 5, that will give us negative 11. Negative 2 times 2 is negative 4. Negative 4 plus 3 is negative 1, and here's negative 1. Negative 2 times negative 3 is positive 6. 6 plus 8, that will give us 14. And we accomplished this step. We got this 0. So we have 1 here, 0 here. We need to make sure that this is 0. How do we make this 0? From the 1 in the same column. Okay? So now we have to make this 0. How do we do this? Well, if we multiply the first row by negative 3 and add it to the third row, then we'll make this 0. So let's do that. Multiply the first row by negative 3 and add it to row 3, R3, that's row 3, and you leave your answer in row 3. So sometimes this is written, for mathematicians usually write it like this. Negative 3 times 1 is negative 3, negative 3 plus 3 is 0, and leave your answer in the third row. Here you have it. Negative 3 times 3 is negative 9. Negative 9 minus 1 is negative 10. Negative 3 times 2 is negative 6. Negative 6 plus 4 is negative 2. Negative 3 times negative 3 is positive 9. 9 plus 7, that would give us 16. So now we're okay with the first column. Next, we have to make this one 1. Negative 11, we're going to transform it to 1. How do we do that? This is where we use the second row operation. We have to multiply a row by non-zero number. So what do I have to multiply row 2 by to get in negative 11? Basically multiply by the, to get this 1, you have to multiply by the reciprocal of this. Reciprocal of negative 11 is negative 1 over 11. You multiply negative 1 over 11 by R2, and that would give us, we're not doing anything to row 1, so I'm going to write row 1 as is. Now multiply the second row by negative 1 over 11. It's not going to change this. It's going to stay 0. Negative 1 over 11 times negative 1. That's going to give me a positive 1. Negative 1 over 11 by negative 1. That's going to make it positive 1 over 11. Yes, you're going to end up with a fraction. A lot of times that's what's going to happen. Usually at the end you'll be okay. A lot of the answers are going to be integers. Negative 1 over 11 times 14, that's negative 14 over 11. So now I made this 0. I'm going to leave the third row as is. Okay, now we're going to make this one 0. So we're done with the first column. We're going to take care of the second column. How do we make 1 0? It's always from the one in the diagonal. If you multiply the second row by 10, what's going to happen? 10 times 1 is 10, 10 minus 10 is 0, and there you have it. So multiply row 2 by 10 and add it to row 3 and put the answer in row 3. Okay, I am not changing row 1, so I'm going to write row 1 as is. Okay, multiply 10 by row 2. By the way, we're not changing row 2 as well. So row 2 is in the right form. The only thing we're left with is row 3. So 10 times 0, remember the 0, this is not going to change. 10 times 0 is 0, 0 plus 0 is 0. 10 times 1 is 10, 10 minus 10 is 0. The answer is 0. Now 10 times 1 is 10 over 11. I can write it if you like here, 10 over 11. add it to negative 2. So a lot of times you're going to end up with a fraction. So this is going to be what? This is going to be 10 minus 22 over 11. Okay, and what is that going to give us? That's going to give us minus 12 over 11. Okay, so it's going to be minus 12 over 11. It will be a good idea for you to leave a piece of paper handy, because sometimes you're going to be writing these answers. We're not done yet. We still have the answer here. So 10 times row 2. So 10 times this. So negative 14 over 11 times 10 plus row 3 plus 16. So that's going to give you, when you get that value, you're going to put it in here. So negative 140 over 11 plus 16. So negative 140 plus 1 over 11. And if you do the math, it should give you 36 over 11. Okay, so a lot of times you're going to end up doing fractions like this. Please don't try to write your answer in decimals. Just leave them in fractions. So the first column, the second column is good. We're almost done. All we need to do is to make this into 1. And it's always easy when you have a fraction. You always multiply by the reciprocal. The reciprocal of negative 12 over 11 is negative 11 over 12. You multiply the third row by negative 11 over 12 and you would be done. So again, we are not changing row 1 and row 2. So we write the numbers as is. And now you multiply, oops, let me get this, it happens sometimes. Okay, multiply row 3 by negative 11 over 12. Again, these won't change, so 0, 0. Negative 11 over 12 times negative 12 over 1, that should give me 1. And now let's do the last one, negative 11 over 12 times 36 over 11. You see how it's going to cancel out nicely? The 11 and the 11 going to cancel out. You still have a negative 1, don't forget that. 36 divided by 12, isn't that 3? So that will give me negative 1 times 3, that's negative 3, and here's your answer. Now we have this, the matrix in row echelon form. Notice the diagonal are all 1, and anything under the diagonal is 0, and now we can easily solve it. How are we going to solve it? We're going to start with the last one. Remember, the first column, it represents the coefficient of x, the second column represents the coefficient of y, the third column represents the coefficient of z. If you notice, we have 0x plus 0y, so you can ignore them if you like. Okay, and you're left with 1z. 1z, or simply z, is equal to negative 3. There you have it. So you don't have to, whenever you see the zeros, just go from there. 1z, z equal to negative 3. Now we'll go to the second one. What does the second row give us? 0x, so you can ignore that, plus 1y, or simply y, plus 1 over 11z, these are the coefficient of z, remember, 1 over 11z equals to negative 14 over 11. So go ahead, plug in z, y plus 1 over 11 times negative 3 equals to negative 14 over 11. So this is going to be y minus 3 over 11 equal to negative 14 over 11. You can, if you want, multiply by the LCD, which is 11. I do not recommend it. Simply add 3 over 11 on the other side. So add on, really you have to add them on both sides. So this is going to cancel. And what are you left with is y equal. Now we have the same denominator. Negative 14 plus 3 is negative 11, right? Over 11. which is -1. So now we have the solution z equal to -3 and y is equal to -1. Okay, so we are good with this. And now we go to the first row, and that will help us solve x because we have y and z. We can solve for x. So remember, these are the coefficient of x, coefficient of y, coefficient of z. So we have 1x, excuse me, so x plus 3y plus 2z equal to -3. Now that we have y and z, we can easily solve for x. So x plus 3y, 3 times -1, plus 2z, 2 times -3, that would help us solve for x. So x, 3 times -1, -3, 2 times -3, -6, equal to -3. So that will be x minus 9 equal to -3. You add 9 on both sides, and that will give us x, this cancels, equal to 6. So we have x, y, and z, right? And you can write the solution as in order triple. The solution as in order triple are x, y, and z. X is 6, y is -1, and z is -3. And this is the way you solve a system of living equation using matrices. You always, one way of solving it, you don't always, one way is by using the row echelon form. The diagonal 1, anything under the diagonal is 0. I hope you find this video helpful. Have a good day, everybody. Bye-bye.